Hello and welcome to a Rogue Entity series on Unreal's Enhanced Input. This series will consist of 4 episodes, all available on my Patreon now, or they'll be released later to the public. Episode 1 examines the basics, how Enhanced Input works, what makes it up, and how to get it going. Episode 2 will go through converting a project to Enhanced Input and implementing different types of inputs. Episode 3 will demonstrate how to use multiple contexts to override inputs for different scenarios. Episode 4 will demonstrate a method of implementing key modifiers such as Shift, Control, and Alt. What's not covered in this video series, but may be covered at a later time, is the key mapping and player rebinding in like a player settings. Episode 1. So in this episode we're going to start with examining the structure of Enhanced Input, what it's made up of and how each part works. We'll demonstrate a basic configuration and an example of the C++ implementation to get you on your way. I'm going to be using the RTS tutorial for this series. So if you haven't used it, if you haven't been going along with the RTS tutorial, then you can just use a blank project. It's not really going to make a difference. It's really only in episode 2 where I want to convert some more advanced inputs rather than ones that come with the default project. That's probably the only difference. And you can just add them anyway instead of converting them. If you're not using UE5, there may be some additional steps that you need to do to get the enhanced input working. So you just need to firstly go to plugins, insert enhanced input, enable that and restart your editor. You'll need to go to your build CSS and add in the public dependency module names, just add the enhanced input. Come on. Enhanced input in there. And then restart your editor. And then once you're back in your editor, go to your project settings, input, and just ensure that the default classes are set to the enhanced input. If you're using Unreal Engine 5 or 5.1 or greater, I think it's 5 or greater, it's all the plugins enabled by default and everything's set up anyway, so you shouldn't have to do any of those steps. So enhanced input consists of 2 main data classes to consider when setting it up. The first one's input action, second one's the input mapping context. So the input action just defines the input value, and you can also include triggers and modifiers in an input action itself, which we'll cover later. And the input mapping context is what stores the actual key input mappings for this action. Similar to what you used to set in the project settings in the old setup, what key does what, and you'd set the inputs in there and stuff like that. You can also assign triggers and modifiers in the input mapping context for each input action, and I'll show that later. It's better off assigning the triggers and modifiers inside the input mapping context, as it by the name says, you want to use those modifiers in that context, whereas another context you might want different modifiers. I think the best way to have a look at them is to actually set something up. So what we're going to do is set up a basic WASD input. So I'm just going to set up some new folder structures. I'm going to make this action context, because we'll have more than one. We'll definitely have lots of actions at some point, and probably more context through the series. So folders are good. So let's create the move action. So input action, and it's IA is usually the abbreviation used, and we're just going to call this move. So when you name your input actions, you want to name them a descriptive name of what the action is doing. Over like a key assignment or something like that. And we'll come back to that. We'll just create a context, so input mapping context, and the usual abbreviation for these is IMC. I've seen IM as well. I'm not sure what the actual naming convention from UE says. And we're just going to call this one default. This will be our default context. So if we open up our IA, and that's going to be annoying, so I'm going to quickly fix that up. So that will make things open into the main window rather than new window. So this is where you set the value type. So the value type is pretty basic. It's just defines what input that you're going to get out of the action. So whether it's just going to be a 0 or 1, a number float, or which is usually 0 to 1 float, and then you axes 2D, 3D, just vector 2 and 3. So it's pretty straightforward. This setting here determines how you're going to need to handle it when you bind the input. So for our move, we're going to set it to a 2D because we're going to want an x-axis and a y-axis to go forward, back, left, right. And that's it. That's all we need to set in here. Now if we go to our context, we add a mapping, and we're going to assign the IA move. For the IA move, we want to assign our W, A, S, and D. I'm actually going to do it WSDA in the order there because it's just an easier way considering what we have to do to them. The consideration here is the default input from an action is just a 0 to 1 number. When we assign multiple input keys like this, we need to tell it what value we want, and we need to use modifiers to do that. If we can only input a value 0 to 1 and we have the multiple keys, we not only need to tell it to invert the value to a negative value for when we want to go backwards, like with S, we also need to tell it that, hey, this is actually a y-axis value, not a x-axis forward and back. So the way that we do that is we assign modifiers. You can actually write your own modifiers if you need to, but Unreal comes with ones you generally need. I haven't actually had to write one myself yet. To set up a WASD thing and invert and change those numbers, there's two modifiers that we're going to use. One is called negate and one is called swizzle. Negate is what just simply inverts our value so we can get a reverse input. So we can turn a 0 to 1 input into a 0 to -1 input to get that backwards or opposite direction. And swizzle, it's an operation that rearranges the components in a vector, and it's actually a term. So this is used to insert values into you can change, by default, all values will be inserted into the X, so you can swizzle it to insert values into the Y. Because we set the input action to a vector 2D, we've got an X and a Y, so we can swizzle it to insert values for the D and the A directions, left and right, into the Y. So let's set that up now. So the first one, W, forward is 0 to 1. Don't need to change anything. S is the reverse of that, so we need to add a modifier and we need to negate it. So now that'll go opposite to forward on the x-axis. So it's going to go negative on the x-axis. Now D, which is technically right, doesn't need to be inverted. It's 0 to 1 is right. But we do need a swizzle, so we're going to swizzle the input axes. And if you look in here, you can actually swizzle to more than just X and Y. You can pretty much do any arrangement. But the default is X, and that's why you don't see X, Y, Z in here. It's the default. So you just take the swizzle out, and that's what it will do. It will store the value into X. So by setting it to Y, X, Z, Y is going to get our value here. Now for the A, it's actually negated we want it to go left, so it's the negated right value. So we're going to need a negate. And we're going to need a swizzle as well because it's the y-axis. So we're going to have two modifiers on the A value. Now while we're in here looking at the modifiers, you can obviously see there's a trigger here as well. The triggers control the condition of the input. You can write your own triggers, and we'll actually do that in one of the later episodes. We'll add a custom trigger. The triggers is what affect the input events. So like a hold trigger on pressing the key, you can set a hold time. Same as, it's all about when the trigger is technically activated. But there is a whole list of input events these triggers influence. There's 5 input events. There's started, which is just like the old press. It means you haven't really triggered the input, you've just started pressing it. And if you don't really need any condition, you can just use that. Ongoing is every frame until the trigger condition is met. So this is where you do some sort of check maybe that you want to do before it's triggered. They're all got their uses here. The triggers are sort of like modifiers for this trigger event, so that, like the hold time is delaying the trigger condition from firing. But normally this is what you'd use to bind a simple input to. You'd want it to go when you trigger the input. Completed and cancelled are called, or the events fire, sorry, when you release the key. The difference is that completed will be if the trigger condition was met, it'll fire the completed at the end and cancel if it doesn't trigger. So you've got a hold time, you don't hold it long enough and you release, you'll fire an input. And this is just to, this makes this system really flexible as to what you can set up for keys and inputs. You don't need to use them all, you don't even need to set them all, you just can use what you want and what you need and how you need it. The other things that you're going to probably want to do with enhanced input is manage your data. You're going to end up with a whole bunch of input action data files. Same with context. You know, like if you've got quite an advanced system, which RTSs, you'd make one of those. They've got heaps of keys and different context. You'll see like a few context examples later in other episodes, but you're going to end up with a few files and a lot of references in your code if you don't organize it properly. I suggest using a data asset file to put them all in, and you can actually put some functions in there as well to help with binding, and that's the setup I'm going to show here. This is not required. You can just put all this stuff directly into your controller class. So if you don't want to set up a data asset file, just anything I put in my data asset, you can just put directly into your player controller or player pawn or wherever you're setting up your key binds. So we're going to go into C++ here. We're going to create a new class, simple data asset. I'm going to call it player input actions. And I'm going to put it in a folder called input. So once that's created, we just need to add some fields for the context and the input action. We also need a context priority here, so it'll just be 0 for this first one, but just add that. References for those. We also need to make the class blueprint live so we can create our asset in the editor. And the other thing I want to add here is a namespace for our input actions. This is basically, we're going to use some macros to create our bindings for inputs. I'm just going to copy in this first binding. So if you remember the input events, this is the trigger event. So it's called trigger only. That's just the name I'm using. You can call that whatever you want. I'm binding an input and I'm binding the trigger only. So it's binding this event triggered. And if you have a look, hang on, it include the enhanced input component. That'll these references sorted. If you have a look in here, you can see there's all those event triggers. I didn't cover none, but I reckon you can figure that one out. We'll be able to pass an input component to bind it to, the action we're going to use, the object it's binding to, so for us it'll be our player pawn, but it could be a player controller, and the function that it's going to call when it is triggered, when this event fires. We'll cover that more when we go to bind an input. And you can have multiple of these, like you can, if you want to bind 2 events at once, and we will do that later. We'll add more to this. So we'll go back into the editor now and create our data asset. Oh, that's just doesn't like custom folders. If anyone knows how to fix that, good. Let me know in the comments. So now we'll go to our input folder. We'll go to data, create a new data asset, and we'll find our player input. We'll call it DA default player input. Save that, open her up, and we can assign our, one of these is from the template, top down, one's ours here. I'm just looking at the path there to get the right one. Yeah, game input context, that's our one. The priority is 0, and that's our move function, our move action. That's all assigned. So now let's set that up in C++ to use. So we're going to start in our player controller, and I'm going to create a new section down here, just called enhanced input. And we're going to need a few functions here. So add and remove the input mappings. We've got a function to set our default input mapping. So if we have when we have multiple later, we can have a function to call just to set that specific one, and we'll default that to true, just so we can just call the function and to enable it, and then call false to disable it. We're going to need a reference to get our data asset. So this will be our data asset that we just created, a reference to it, and we needed a function to be able to retrieve it. So when we're binding actions on the player pawn, we can grab the action assets and reference our assets, and we're going to need to override our setup input component on our player controller. So I'm just gonna generate the definitions of those new functions. Hopefully B's nice, puts them down the bottom, yep. I'm just gonna bring over my little title here, just to keep it separate. Unwrap. Now in here, we're going to need to get a reference to our enhanced input subsystem, adding a mapping context. So that's going to need to include the enhanced input subsystem. So that'll load the subsystem, so we've got access to it. We want to just ensure our input mapping we're passing in is not null. So if we haven't set it in our data asset or something stupid, this should stop the game from crashing and just give us an error. And that'll only happen in the editor and on the build using the ensure. We want to check that the first thing we need to check is if the mapping context is already loaded, and if it's not, if it doesn't have that context, then we will add it. And then removing is almost the same, except we just call an ensure in there, make sure it's good, and then we'll remove the mapping context. Now to set up our default input mapping, we're basically going to use these functions here to call add if it's enabled and remove if it's false. Put a little reminder message in for us if we forget to set our context in the data asset. We're going to get a reference to our data asset and cast it to player input actions, which is our custom data class that we created. So now we should be able to access all our data in our mapping context and our actions. So we'll just ensure that the mapping context is assigned, and I'll show you what this displays. Now we either want to add it or remove it depending if we pass true or false in. So it's going to pass true by default, but if we pass false, we want it to remove the mapping. So we can quickly enable or disable a context just by calling this function now. Input component override, we want to do the same thing again, get the input subsystem. And when this originally executes, what we want to do is clear all mappings and then assign our default one. So this will be what sets up our keys initially on the load of the game. That's our player controller ready to go. So now we need to set up our pawn. I'm going to do the same thing. I'm going to create a little section at the bottom. Before we set that, I'm going to go to our player input component here, and I'm going to disable all our current inputs. So now we have no inputs. So in here we need to do a couple extra steps. We need to get the enhanced input component, which is a cast from our player input component. We're going to need a reference to our player controller, which we should already have, I think, on this class, but I'm just going to yeah, there it is there. But I'm just going to put a new one in case the other one's not loaded yet or something. So that's our player controller. So now we'll use that to get a reference to our data asset. So we just want to set up our action bindings now. So we'll validate that we've got those two references that we need. We'll get a reference to our player actions from our player controller. And now this is where we use the macro that we set up in the data asset. So we can just use the namespace that we set up, which is player input actions, and we can just bind the input trigger only. So there's that function there. The first thing is the input component, which you can see above is just named it input. And then we'll ask them what action are we binding to, and then we're binding to our player actions, which is our data asset, move. And the object we're binding to is this, player pawn. And the function we want to call when this action is triggered is something we haven't created yet. Cannot type. And we're just going to call it move. So if you recall, when we normally do, or the previous setup had forward and right to do that, we've got it all in WASD here in an action called move. So let's set up that function ready to go. And the only difference between enhanced input functions and other functions is it takes a struct, which is the input action, the value. The value is a struct, it's not just a float. And to allow that to work, we need to include input action value. So let's just add that input action value. That should sort that out. And then we'll implement this. Now, if we compare this move to forward, so if we have a look at forward, it's nearly the same. So we're going to take some of this. We don't need to check to see if the value is 0 because enhanced input doesn't do anything if it's 0, unlike the old system. We will do some checks actually. We'll just check our spring arm component is not null or something stupid. What we need to change here is rather than just get the forward vector and add a number to it, we're actually going to rotate a vector by the input, the value that we get back from the input. We don't need target location. This is a plus equals. So we're just adding to target location by direction that we're getting because we've got the XY coordinates coming through now. We do need to check, it's a good idea to ensure that the value is the type that we are looking for. We're not going to do this unless it is. So we're checking that it's an axis 2D, and there's two functions you're basically going to use from this struct, and it's get value type, and the other one is just the value get. So you just, we're going to call value get, and then we have to just tell it the type that we're expecting back. And we're expecting back an F vector. That should be our move ready to go. Before we go back to the editor, I am just going to turn something off. Where is my tick? Let's move these up. So in the tick, I'm just going to turn off edge scrolling because it's not using a keybind and it's annoying. Right, let's go back to the editor. The first thing we would normally need to do is go to our player controller that we're using for the map and assign our player actions data asset here. You can see if I don't assign it, we get this. So it didn't crash the game, but it's saying, hey, this is null. Need to sort that out. Which is handy. So we'll assign that. Cross our fingers. And there we have movement, W, D, A, and S. So that concludes episode 1. In episode 2, we're going to look at converting more of our current RTS project over to enhanced input and experiment with some different input types, input values. As I mentioned at the start of the video, all videos are available now on Patreon. Thanks for watching. See you next time.